Why clean agent gaseous extinguishing then? Well, gaseous extinguishants have a specific design purpose as an effective medium for the extinction of inflammable liquid fires and fires in the presence of electrical and ordinary Class A hazards. But it should not be forgotten in the planning of comprehensive schemes that there may be hazards for which these media are not suitable, or that in certain circumstances or situations there may be dangers in their use requiring special precautions. The appropriate fire authority, the health and safety authorities and insurers all have valuable input to the consideration of these, as indeed do the prevailing national standards and statutory regulations of the particular country. These clean agents are designed to operate in limited spaces where there is a need for speed of suppression given the asset risk and where the space is occupied by people. They have to extinguish a fire without damaging the asset that they protect. They must extinguish the fire and enable business continuity of the asset whilst power is maintained to the asset so it continues to function. They must be easily maintained in situ, and they must comply with the NFPA 2001 standards demanding fast discharge in 10 seconds and fire extinguishing within 30 seconds. Protecting humans and equipment alike whilst doing so in an environmental manner in regard to ozone depletion and governed by the Montreal Protocol. They must be non-flammable and non-toxic, contained in a design parameter which is state of the art, and deliver confidence to the operator that it delivers best fire safety practice. But the ISO standard specifies its accidental discharge or leakage potential without calling for its constant monitoring. Any other pressurised system is permanently monitored, but not the active fire systems, which stays in its own shadows. Cylinders accidentally discharge. CO2 can cause fatalities if it does. 1% of pressure gauges fail and 25% of valves do too. In Germany, they constantly monitor at the cylinder's weakest point, and that is the cylinder neck. Now, this is a haphazard approach to the complex engineering world a dynamic pressurised fire system exists in. Pressure gauges themselves are prone to problems because if they have a pressure gauge which is stuck on the same position for 12 months, it may stay like this, and so the pressure did fall, it might not show the fall because it won't move. That is why they use a vacuum test when they test the pressure gauges to ensure the needle does move freely.